Dumelang, hello. This is gonna be our next Macaulay question, right? And we have our beautiful beam right here, right? Which I'm gonna, like as always, I'm gonna draw it again, right? So that we can solve it. Okay. We have our beam. We have our beam here, right? Okay. And then you can see the UDL that it's not in the end, right? So we're gonna have to extend it at the top and at the bottom, right? So yes, go down, 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 and down in a DM, right? So here we have 30 kilonewtons per meter, yeah. And then here is B, here's A, here's C, and then from here to here is 3 meters, from here to here is 2 meters, right? From here, here, and then okay. Now I'm gonna draw it again, make everything into point form, right? So that it's easy to solve. But I don't think there's a need. Is there? Okay, I don't think there's a need. Why? Okay, there is. Is there? Yeah, I think there is. But then if we're taking our Macaulay from this side, right, we're gonna cut it just before the end. So there's no need to find this reaction and moment. Just before the end, we're gonna cut it somewhere here. So this is gonna be our starting point, and this is X, right? Now, because our UDL doesn't end here, like it's not extended to the fullest, we have to extend it and then also at the bottom. So here's how we're going to draw it. Going to be, here's where we cut it, and then here's C, so it's gonna be, right? Might as well finish it, right? So it's gonna end here. You see, we extended it from here, right? So it's gonna go down, 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 down in a DM, right? And also at the bottom, because we cut it from here. So it's also gonna get extended here at the bottom. Okay. So here's gonna go up, 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 right? So this is how it's going to be. See, the same 30 kilonewtons per meter. And then here's how is it. So here is still, no, we don't know how much, like the distance from here to where we cut it, we don't know it. But then what we do know is the distance from here to here. From here to here, we know that it's still 3 meters. But then from here to here, we don't know. From here to here, we don't know, right? Okay. So, but then we do know that from here to here is X. From where we cut it here is X, right? Okay. Now I'm gonna do my Macaulay EI or dy, right? It's equals to minus m, right? And then I'm gonna take my moments. My moments is what? Moments about here, right? So this, everything is gonna be pushing it clockwise. If we hold it here, hold it like this, it's gonna be pushing it clockwise, and all this is gonna be in the opposite. That means it's gonna be pushing it where? Anti-clockwise, right? So this is a UDL. We don't know the whole distance here. We do know the whole distance is 30, is X, right? So the UDL is 30 multiplied by x, which is 30x, right? And then multiply by half, because it's gonna be in the middle. It's gonna be somewhere here. So it's gonna be multiplied by half of the whole distance, which is x, right? And then minus this one. We do know that also is 30 kilonewtons per meter. 30 kilonewtons per meter, right? And do we know the distance from the middle, from here, right, to here? So if we make it a point load, it's going to be 30, right? 30 multiplied by x minus 2 multiplied by multiplied by x minus 3, not 2, because we know that from here to here is 3. So 30 multiplied by x minus 3. X minus 3 is the distance from here to here, right? So this is still a point load, and then let's multiply by the distance, which is the distance from here to the end, right? It is half of x minus 3. So it's going to be like this, right? So that means my m is equals to 30 multiplied by half, which is 15x squared, right? And then here minus is going to be minus 30 multiplied by x minus 3 multiplied by half x minus 3. It's going to be still 15, right? And then x minus 3 squared, x minus 3 squared, right? So here's how it is. Next page. Okay. Now in our next page, I'm just gonna substitute it here, right? EI. This one already we know that we wanna be given, right? Squared, and then dy squared, right? Is equals to minus 15x squared, right? Plus 15x minus 3 squared, right? Okay, now we integrate. It's gonna be ei dx over dy is equals to, I hope I'm not moving too fast, but minus 15x squared, x cube, x cube over 3, right? Plus 15x minus 3 cube over 3. The same, no cube here, right? Okay, now for the last time integrating, EI is equal to y, which is the deflection. This is the slope. We know that number one is the slope, and this one is going to be the deflection, right? So it's going to be minus 15x to the power of 4 over 4 multiplied by 3, right? And then plus the same 15x minus 3 cube over, not cube, but 4. It's easy to make mistakes, so you better watch out. 4 multiplied by 3, which is, this one is going to be the deflection. You know, I forget something, and I always forget this. The slope, when we integrate, I forgot to plug the C1 and the C2. So, okay, this one you can cancel out. I know you probably saw the mistake already, right? So EI dx dy is equals to this one, this for the slope, minus 15x cube over 3, right? Plus C1, yes, plus C1, right? And then plus 15x minus 3 cube over 3. Yes, this is the formula of the slope. Don't forget the C1 and the C2, right? So this one is like this one, but then I at first I didn't add the C1, right? Hey, what's there? Okay, and then EI EI, so that's why I'm saying it's easy to make mistakes here. So you better watch out. EI y is equals to, this is gonna be the deflection formula, right? It's gonna be minus 15x to the power 4 over 4 times 3, right? Plus c1x, right? Plus c2, right? And then plus 15x minus 3 to the power 4 over 4 times 3, right? This is the deflection. So this, okay, let me cancel this ones, right? This is for the slope and this is for the deflection, right? So now let's find the C1 and the C2. Now I'm gonna write the boundaries, right? The boundaries, right? Boundaries, boundaries, right? We know that the boundaries at x is equals to, at x is equals to 5, and at x is equals to 5, the deflection and the slope is 0, right? Remember here, this is it's not the same as at the reaction, so the slope as well is gonna be 0. So dx over dy is equals to 0 and y is equals to 0, right? Now that I got my boundaries right, I need to find c1 and c2, right? So I know that my slope equation is this one, right? So I'm just gonna substitute x equals to 5 and 0, right? Therefore, at 0, I'm gonna this one slope, right? Therefore, slope at 0 is equals to minus 15, right? X cube, my x is 5 over 3, right? Plus c1, right? And then plus 15, and then x minus 3 cube as well, right? And then over 3, right? I'm just gonna put everything into the calculator, right? Therefore, my c1 is equals to, so it's going to be minus 15 multiplied by 5 to the power cube over 3, right? Over 3 plus 15, 5 minus 3 cube over 3, which is minus 585, and then you take to the next side, which is 585, right? Okay, now found my c1, right, using this boundary. Now I can use this boundary for the deflection and find my c2, right? So my boundary at the on the deflection side, we know 0 is equals to minus 15 5 to the power 4, which is this one, right? Minus 15 5 to the power 4 over 12, right? Plus c1x plus 585 multiplied by 5, right? And then plus c2 right? And then plus 15 multiplied by 5 minus 3 over 12, right? Therefore, c2 is equals to, now I'm just going to put everything in the calculator again, which is minus 15 5 to the power 4 over 12, right? Plus 585 multiplied by 5, right? And then plus, plus 15 multiplied by 5 minus 3, right? And then over 12, right? Which gives me 2146, right? I hope I did everything correct. Minus 15 multiplied by 5 plus 5, 8. 585, right? 585 multiplied by 5, right? And then plus 15 minus 3 to the power 4 here, to the power 4, which gives me C2, which is minus 2163.75, right? Okay, now I found my C1 and my C2. Now it's only a matter of substituting back here. So if you want your slope if you want a deflection maybe at 2, you can just input X, input C2 you given, input C1, input C2 you found, input C1 you found, and EI will be given, right? So you can find your deflection at any point. All right. And that is all for this question, because everything from here, EI will be given, young modulus. It's only a matter of substituting, so it's simple, right? Okay, this is the last question, the last paper, second paper, and the first paper. And I'll see you guys in the next question. Mashallah.